Hey there, we're going to be converting complex numbers from rectangular form into polar form. And so we'll be starting with the form z is equal to x plus yi, where x is the real part and y is the imaginary part. Okay, so the first step in converting to polar form is to find the modulus, or the distance away from the origin. Using the distance formula here, r is equal to square root of x squared plus y squared. Once you have that done, the next step is to solve for the argument, or the angle, using either this equation, x is equal to r cos theta, or this equation, y is equal to r sine theta. And make sure to check which quadrant the complex number is in to make sure you have found the right angle. Once you have both those pieces of information, you can put them into the polar form here. Z is equal to r cis theta, and cis theta here is just a short form way of writing cos theta plus I sine theta, but I'm just going to be writing this form in my solutions. Okay, the first problem, what's the first step? Is going to be define the modulus. So we're going to use this formula here. Here we are only given the real part, so this is only x, and y is actually going to be 0. I can also write this complex number as 3 plus 0i. And so we can plug in the x here, that's going to be 3 squared, and our y is 0, and so we get square root of 9, and that's equal to 3. Once we have that, I'm going to use one of my equations to solve for the argument, and I'm going to pick x is equal to r cos theta because we are given an x value. And so we can plug in our value for x, which is 3, and our value for r, which is 3 as well. Cos theta here, divide both sides by 3, and I get cosine of theta is equal to 1. We notice that if we graph this complex number, it's going to be like this. It's going to lie on the positive x-axis. And so that means if we're going to solve for theta here, theta is going to be equal to 0. Okay, so we have our angle or argument here, and we have our value for r, and so we can write this number into polar form. So it's going to be 3 cis 0.
Okay, so for number 2 right here, we don't have, so we put it in the z equals 4i format, right? And we can see that x doesn't have a value, so x is equal to 0. And then y is equal to 1. My bad, 4. And then, so that means that r is equal to the square root of 0 to the power of 2 plus 4 to the power of 2, which is basically equal to 4. So now we have x is x doesn't equal to anything. So we just do y equals to 4 sine of theta. And then that basically means that 4 is equal to 4 sine of theta. So sine of theta is equal to 1. And theta is pi over 2. Yeah, so 4i is equal to 4i is equal to 4 times 4 times cis theta over 2.
Okay, this one, let's solve for the modulus. We are given both an x and y here, so we can plug that in. That's going to be 8 squared plus negative 4 squared. And that's going to give me a square root of 80. And if we simplify that, we get 4 square root of 5. Now I'm going to use one of the equations to solve for the argument. And I'm going to pick y is equal to r sine theta here. It doesn't really matter which equation you use, they'll both be the same. But just kind of look at your numbers and pick the equation that will make it easier to work with. So I'm going to plug in my value for y, which is negative 4. The value for r is 4 square root of 5. We put sine theta here. Simplify, we get negative 1 over square root of 5 is equal to sine theta. Now this is not one of the nice numbers to solve for, and so I'm just going to write theta as being equal to inverse sine of negative 1 over square root of 5. And I'm going to leave it like that. Looking at this complex number, we're going to be in quadrant 4. It's going to be somewhere down here. And inverse sine, the range of inverse sine is between negative pi over 2 and pi over 2, which means that evaluating this will give us the angle that we want in quadrant 4. Now we have everything we need, and let's just write it in polar form.
Z is equal to, so we put it back in that form, Z is equal to 1 plus I. And then X is equal to 1, Y is equal to 1. And so our R is equal to the square root of 1 to the power of 2 plus another 1 to the power of 2. You use square root of 2, right? And then, so X is equal to the square root of 2 times cosine of theta. And Y is equal to square root of 2 times sine of theta. So you substitute in the values like you written there. So it's Y is equal to 1 is equal to square root of 2 times sine of theta 2. And then that would mean that if you cosine of theta is equal to square root of 2 over, okay, well, square root of 2 over 2. And then sine of theta is also equal to square root of 2 over 2. And theta becomes pi over 4. So the equation would become square root of 2 CIS pi over 4.
Okay, question 5. Let's solve for the modulus. Our x is 3 and our y is 4. That becomes square root of 25, which is equal to 5. I'm going to pick x equal to r cos theta to solve for my argument. I'm going to plug in our value for x and our value for r. That becomes 3 over 5, which is not a nice number to solve for. And so I'm just going to leave this as inverse cosine of 3 over 5. Our complex number is going to be in quadrant 1 here, as both of these components are positive. And inverse cosine has a range between 0 and pi. And so inverse cosine is going to output an angle in this part of the plane. And our complex number happens to be in that range, and so our angle will be correct here. Therefore, we can write this as 5 cis of inverse cosine of 3 over 5.
Oh, okay. So this one we also put into the Z is equal to 1 minus I. So our X becomes 1, and then Y is equal to negative 1. So our R is equal to the square root of 1 plus to the power of 2 plus negative 2 in parentheses. Negative 1 in parentheses to the power of 2, which becomes square root of 2. And X is equal to the square root of 2 times cosine of theta. And Y is equal to the square root of 2 times sine of theta. So we have 1 is equal to the square root of 2 cosine of theta. And then the other one is negative 1 is equal to the square root of 2 times sine theta. So this becomes like cosine of theta is equal to square root of 2 over 2. And the other one becomes sine of theta is equal to square root, negative. So now like we have to find like the theta that matches like a negative sine and a positive cosine. So that would be if you want to put it in negative, it would be negative pi over 4. Yeah, negative pi over 4. Is that correct? Yeah. And then so it will become square root of 2 times CIS negative pi over 4. All right, so for this one, we once again put in the form z is equal to negative 2 plus 2i. And then x is equal to negative 2. And then y is equal to 2. And so r would be equal to the square root of negative 2 in parentheses to the power of 2 plus 2 to the power of 2, which becomes that's like 8, right? So that would be 2 times the square root of 2, yeah. X is equal to 2 times the square root of 2 times cosine of theta, and then y is equal to 2 times the square root of 2 times sine of theta. So x is negative, so it's negative 2 is equal to 2 times the square root of 2 times cosine theta, and then it would for y would be 2, so it's just positive 2. And then we simplify that out, so it's negative 1. Oh, okay, well, we'll just do the entire thing. So it would be negative square root 2 over 2 is equal to cosine theta. And then this one would be positive square root 2 over 2 sine of theta is equal to sine of theta. And then so theta becomes a positive sine and a negative cosine. So that would be 3 pi over 4. Yeah, and that would become 2 times the square. So that would the equation would convert to 2 times the square root of 2 CIS 3 pi over 4.
Question 8, we solve for the modulus here. Our x is going to be 6 and our y is going to be negative 8. This becomes square root of 100, which is equal to 10. Now I'm going to pick x is equal to r cos theta to solve for my angle. Plug in the values for x and r, and I get 3 over 5 is equal to cos theta. And this is not a nice number to solve for, and so I will write this as theta is equal to the inverse cosine of 3 over 5. But wait, we're going to have to put a negative here, because if we look at the complex number here, the real part is going to be positive, so it's going to go this way. But then our imaginary part is negative, and so we're going to end up somewhere in quadrant 4. However, we know that the range of inverse cosine is only going to be between 0 and pi, and so we'll only output an angle that is in this range here. But our angle that we want is this. And so what evaluating inverse cosine of 3 over 5 will give us is actually going to be this angle in the first quadrant here. But we want the angle of that but reflected over the x-axis, and so we have to put a negative there. Okay, so once we have that, we can write this as 10 cis of negative inverse cosine of 3 over 5. Okay, question 9, let's solve for the modulus. Our x is negative 1 here, and our y is also equal to negative 1. So we get square root of 2. I'm going to use x is equal to r cos theta. Plug in my value for x, my value for r. Solve for cos theta. We get cos theta is equal to negative 1 over square root of 2. We see that this complex number is going to be in quadrant 3. So here. And so our theta is going to be equal to 5 pi over 4. This is one of the nice numbers that you can do in your head. If you use inverse cosine, it would give you this angle here, right? But we actually want this angle here. And so if you were to use inverse cosine, then you would have to put a negative on that. But this is one of the nice numbers, so we can do it in our head. Therefore, we can write this as square root of 2 cis of 5 pi over 4.
So once again, put in form. Z is equal to negative 3i. And then, so x is equal to 0 because there's no regular number. And then y is equal to negative 3. And so r is equal to the square root of 0 to the power of 2 plus negative 3 in parentheses to the power of 2, which becomes just 3. Well, okay, yeah. And then, so we have y is equal to 3 times sine of theta. And then, so that would be negative 3. So we simplify that to negative 1 is equal to sine of theta. And then we can also do 0 is equal to 3 times cosine of theta. And so that would just be cosine of theta is equal to 0. So we find the value that's of theta that is negative 1 for sine and 0 for cosine, which would be for sine, right? Okay, yeah, which would be negative pi over 2. So the resulting equation would become 3 times CIS negative pi over 2.
Question 11, we will solve for the modulus. 7 squared plus 24 squared. That's going to be equal to the square root of 625, which is equal to 25. I'm going to use x is equal to r cos theta because I see that 7 is a lot less than 24, and so hopefully it's going to be easier to work with. So I'm going to put in my values here. Get 7 over 25 is equal to cosine of theta. This is not a nice number, and so I'm going to use the inverse cosine here. Just leave it as that. We see this complex number is going to be in quadrant 1, and that is within the range of inverse cosine, and so I don't need to do anything to change this to be the correct angle, and so we already have the correct angle, and therefore we can write this as 25 cis of inverse cosine 7 over 25.
So we have z is equal to 10 minus 10i. So x becomes 10 and y becomes negative 10. So what happens is r becomes the square root of 10 to the power of 2 plus, in parentheses, negative 10 to the power of 2. So that becomes 200, square root of 200. Yeah, so 10 times the square root of 2. So, yeah, so that means that x is equal to 10 times the square root of 2 times cosine of theta. And y is equal to 10 times the square root of 2 times sine of theta. And so x becomes 10. 10 is equal to 10 times the square root of 2 times cosine of theta. And negative 10 is equal to 10 times the square root of 2 times sine theta. So if we simplify these two equations, it becomes the square root of 2 over 2 is equal to cosine of theta. And negative square root of 2 over 2 is equal to sine of theta. So the negative, okay, So we need to find something. So sine is negative and cosine is positive. So that would mean that it would be negative. The theta is equal to negative pi over 4. So that would mean that the equation would equal to 10 times the square root of 2 times CIS in parentheses negative pi over 4.
Okay, question 13, we solve for the modulus. Equal to square root of 25 is equal to 5. I'm going to use x is equal to r cos theta because I don't want to deal with a negative. 4 is equal to 5 cosine of theta. Get cosine of theta is equal to 4 over 5. And this is not a nice number, so I'm just going to leave this as the inverse cosine of 4 over 5. We see that this complex number is going to be in quadrant 4, which is out of the range of inverse cosine. And so I'm going to have to put a negative here in order to get the correct angle. Because if I just do the inverse cosine of 4 over 5, that's going to give me an angle in quadrant 1. But the complex number is going to be somewhere in quadrant 4, and so I need to put the negative of that angle in order to get the correct angle. Okay, so we can write this as 5 cis of negative inverse cosine of 4 over 5. Okay, question 14. Let's solve for the modulus. We've got negative 5 squared plus 12 squared, which is going to be equal to square root of 169, which is equal to 13. Let's use r is equal to r, x is equal to r cos theta here. Get negative 5 is equal to 13 cosine of theta. Negative 5 over 13 is equal to cosine of theta. And this is not a nice number, so I'm going to leave it in terms of inverse cosine here. Negative 5 over 13. This complex number is going to be in quadrant 2, right? Because our real part is negative, and so we're going to be somewhere over here. And then our imaginary part is positive, so then we're going to go up, and so it's going to be somewhere in quadrant 2 here. Okay, and that is within the range of inverse cosine, and so I don't need to do anything to this angle here, and therefore we can write this as 13 cis of inverse cosine of negative 5 over 13. Okay. This question, we're going to have x and y both equal to 0.5. That turns out to be square root of 0.5, which is equal to square root of 1 over 2. And if I rationalize the denominator, this becomes square root of 2 over 2. Since both of the parts are the same in the complex number, it doesn't matter which equation I use. I'm just going to pick this one. Plug in my value for x, plug in my value for r, and divide both sides by the square root of 2 over 2, and that gives me 1 over square root of 2. And this is going to be in quadrant 1. And this is also a nice number to solve for, and this happens to be pi over 4 for the angle in quadrant 1. Okay, now we have everything we need. Let's write this as square root of 2 over 2 cis of pi over 4.
Okay, so for this one we have z is equal to the square root of 3 plus I. And x is equal to the square root of 3. And y is equal to 1. So r is equal to the square root of, in parentheses, square root of 3 to the power of 2 plus 1 to the power of 2, which is equal to square root of 3 plus 1, which is equal to the square root of 4, which is 2. And x is equal to 2 times cosine of theta, and y is equal to 2 times the sine of theta. So that would mean that square root of 3 is equal to 2 times the cosine of theta. And 1 is equal to 2 times sine of theta. So simplifying that, we get square root of 3 over 2 is equal to cosine of theta. And 1 over 2 is equal to sine of theta. So that would be that theta is equal to pi over 6. And z is equal to 2 times CIS. Oh, well, the equation is equal to 2 times CIS pi over 6.
Question 17. Solve for the modulus. It's going to be 3 squared plus negative 4 square root of 3 squared, which is going to be 9 plus 16 times 3, which is equal to square root of 57. I don't want to deal with the square root, so I'm just going to want to work with x, and so I'm going to pick x is equal to arc cosine of theta to find my angle. Plug in my values. Okay, divide both sides by square root of 57. And this is definitely not a nice number, and so theta is going to be equal to inverse cosine of 3 over square root of 57. This is going to be in quadrant 4, which is out of the range of inverse cosine, so I'm going to have to put a negative here in order to get the right angle. Now we have everything we need. Let's write this as square root of 57 consists of negative inverse cosine of 3 over square root of 57. Question 18. Solve for the modulus. Get negative 1 squared plus square root of 3 squared. That's going to be equal to square root of 4, which is just 2. Let's use x is equal to arc cos theta to solve for our argument. Plug in our values. Get cosine of theta is equal to negative 1 over 2. We see that this is going to be in quadrant 2, and the angle for this in quadrant 2 is going to be 2 pi over 3. This is one of the nice numbers that you can do in your head. Okay, let's write this as 2 consists of 2 pi over 3. Okay. Question 19. Modulus is going to be negative 7 squared plus negative 24 squared. That's going to give you square root of 625, which is equal to 25. I'm going to use x is equal to r cosine of theta. Plug in my values for x and r. We get cosine of theta is equal to negative 7 over 25. And this is not a nice number to solve for, and so I'm just going to leave it as inverse cosine of negative 7 over 25. Checking the quadrant, this is going to be in quadrant 3, which is out of the range of inverse cosine, and so putting a negative there will give me the right angle, and we get 25 consists of negative inverse cosine of negative 7 over 25. Okay.
And then for this one, we have z is equal to 1 over 2 plus square root of 3 over 2 times I, yeah. And then x is equal to 1 over 2. And y is equal to the square root of 3 over 2. And so r is equal to the square root of 1 over 2 to the power of 2. And so r is equal to the square root of 1 over 2 plus, my bad, to the power of 2 plus square root of 3 over 2 to the power of 2. So what that equals to is the square root of 1 over 4 plus 3 over 4, which equals to the square root of 1, which is just 1. And so x is equal to 1 times cosine of theta, and y is equal to 1 times sine of theta. And so cosine, so 1 over 2 is equal to cosine of theta. And square root of 3 over 2 is equal to sine of theta. And so theta is equal to pi over 3, which means that the equation becomes 1 times CIS square root, pi over 3.
Question 21, solve for the modulus here. We get negative 2 squared plus negative 2 square root of 3, all squared. It's going to be equal to 4 plus 12, all square root. That's equal to the square root of 16, which is equal to 4. I'm going to use x is equal to r cos theta to avoid having to deal with the square root here. And so, if we plug in our values, we get negative 2 is equal to 4 cosine of theta. We get cosine of theta is equal to negative 1 over 2. I notice that this is in quadrant 3, and this is a nice number to solve for, and so I'm just going to do it in my head. We get 4 pi over 3 for our quadrant 3 angle. Therefore, we can write this as 4 cis of 4 pi over 3. Question 22, we solve for the modulus. 1 over square root of 2 all squared plus 1 over square root of 2 all squared. That square rooted is equal to 1 over 2 plus 1 over 2 all square root, which is equal to 1. And it doesn't matter which equation I choose, I'm just going to use the x is equal to r cos theta, plug in my values. This just happens to be cosine of theta is equal to 1 over square root of 2. This is a nice number, and also we're going to be in quadrant 1, and so this angle is going to be pi over 4. Okay, now we have everything we need. Let's write this as 1 cis of pi over 4. This 1 is kind of redundant, so I can just write this as cis of pi over 4. Okay. Question 23. Let's find the modulus. Negative square root of 3 squared plus negative 1 squared. Okay, that's going to be 3 plus 1, which is equal to square root of 4, which is equal to 2. Okay, I'm going to choose y is equal to r sine theta, because I don't want to work with the square root. Plug in my value for y. Negative 1 is equal to 2 sine theta. This gives me sine theta is equal to negative 1 over 2. Let me see, this is going to be in quadrant 3, and this is also a nice number, and so I'm doing this in my head. This is going to be 7 pi over 6 for the angle. Therefore, we can write this as 2 cis of 7 pi over 6. Next question, r is equal to square root of 3 over 2 squared plus negative square root of 3 over 2 squared. That gives us 9 over 4 plus 3 over 4, which is equal to square root of 12 over 4, which is square root of 3. Okay, I'm going to choose x is equal to r cosine of theta to solve for my argument. Plug in my numbers. Okay. Divide both sides by square root of 3. 3 over 2 square root of 3 is equal to cosine of theta. We go over here. This can, if we rationalize the denominator, 3 square root of 3 over 6, that actually ends up being square root of 3 over 2 is equal to cosine of theta. That is a nice number. We check the quadrant. This is going to be in quadrant 4. And so I am going to put negative pi over 6 here, because that's going to be the right angle. And also keep in mind that there are infinite many possibilities for this angle, because you can just add 2 pi or minus 2 pi. Okay, so we can write this as square root of 3 cis of negative pi over 6. Or it could also be like 11 pi over 6. Question 25. Find the modulus, negative 12 squared plus negative 5 square root of 3 squared. That's going to give us square root of 144 plus 75, which is equal to square root of 219. Okay, solving for the angle, I'm going to use x is equal to r cosine of theta, plug in the numbers, divide both sides, and we get negative 12 over square root of 219 is equal to cosine theta. That's definitely not a nice number. And so I'm going to leave my angle as the inverse cosine of negative 12 over square root of 219. This is going to be in quadrant 4, which is out of the range of inverse cosine, and so I'm going to have to put a negative here in order to get the right angle. Therefore, we can write this as square root of 219 cis of negative inverse cosine of negative 12 over square root of 219. Oops. Okay. That's all the problems for this video, and I hope it helped. Thanks for watching.